I gave you guys some definitions of surface subtraction versus spatial subtraction, but I don't remember if I actually brought out the examples of them. Okay, so most of you know this is what was due for today. This is this is an example of the surface subtraction. So all of the cuts for this are skin deep, right? They're the thickness of whatever the skin of the object is. These cuts do not reduce the volume of this cube. Okay, so this cube is, you know, if it's 24 by 24 by 24, it's whatever that is in cubic feet. This, on the other hand, is an example of spatial subtraction. Okay, and you can see that you understand this as being subtractions on the surface. This you can see as subtractions that are being sort of carved out of the space. And in this one, you can clearly see, right, the reduction in volume of the space. Now we do subtraction for different reasons, whether it's, you know, to sculpt something or to articulate and add visual interest to something, or potentially to create useful spaces. So in the particular case of this, we've taken out these scoops that create a porch and a walkway on the outside and create kind of a skylight coming down, even though this isn't a building. Okay. But we've done those subtractions for both a sculptural, aesthetic, articulative purpose as well as a functional reason. Okay? All right. So today, this is what we're going to undertake. We're going to undertake creating this exact set, not these, but this exact set of spatial subtractions. Okay? And we're going to do it in 3 stages. We're going to take an initial large scoop out right here, all right? And we're not going to think about the other 2 at that point. We're just going to do the 1. Then once we finish that one, then we'll do the second small one up here, right? And add to this first subtraction. And then when that's done, then we'll work on the third, okay? So we'll take it in those logical steps. I have a handout for you guys, so please only take one of these. I'll keep a couple for myself because God knows what happens. Please pass those around. Make sure you get a copy of it. I was assured by my Monday, Wednesday class that you guys can read those numbers. And I walk around to everyone. Can you read this number? Can you read this number? Can you read it? Yeah. So if you can't read those numbers, then we'll have to get a pair of magnifying glasses and kind of write them larger. Okay? All right, so this document is outlining the 3 subtractions that I just mentioned to you. All right, and the very first thing that we have to do with this one is to start with the first subtraction is to lay it out. Now, I don't want to build an extra box, so I'm just going to use the back half of the one I used to talk to you guys about the surface subtractions. Okay, so I'm going to start out by laying out that first. I'm going to start by laying out that first subtraction, and to do that, as we have been doing before, we need the scale, we need the pencil, we need one of the triangles. Okay, so all right. So if I look at this object, right, and I'm going to turn it upside down to me so it's right side up to you guys, okay? What we're trying to do, if I hold this cube up in this fashion, it sort of matches that view, right? So what we need to do is to think in terms of, all right, where are we cutting from? And so we're going to be cutting an opening here, and we're going to be cutting a smaller opening here. All right, and notice that I'm marking it in that relationship. I've had students that get confused, and like they're looking at the drawing one way, but they're looking at their model the other way, and they go in the opposite direction. They put the big cut over here and the short one over here. So I'm just warning you guys in advance, if you kind of hold the 2 things so that this top corner and that top corner are both facing up, then you have a better chance of sort of matching it. So I'm going to kind of take the dimensions from here, and I'm going to kind of transpose them over to here. So I'm going to put an arrow this way, and I'm going to write 14 feet. That's that dimension right there, 14 feet. Okay? Now, when I look at the side, it looks like I go up 4, then 16, and then 4 more. Okay? So now I'm going to kind of make a note, 4 feet, then an arrow this way, 16 feet, and then 4 feet. All right? And then finally over here, it's 6 feet. All right? So now I'm going to use my scale. So I take the scale, 1/4 inch to a foot, and I'm going to lay it on this edge. And I'm going to come up and I'm going to put a mark at 4. I'm going to come down 4. Verify that the middle is 14 feet or 16 feet. And there it is. Okay, so there's my 2 marks, right? Now I need to scribe lines sideways in this direction. So here goes for that. Slide that forward. And I'm using that same technique of laying the box and the triangle both down on the table. All right, and so there is that line and that line scribed in here. Now I've got to measure over 14. So take my scale, 1/4 inch to a foot, mark the 14-foot point. And I'm going to stand up so I can see over the edge here. All right, and so there is one of the corners that I have to cut out. So I'm going to kind of just hatch that in to the camera and that you all can see it. Okay, and that represents this face right there. Okay, all right. Now going the other direction, same thing as we did before. You learn to project around a corner. So I'm going to do the same thing. I'm going to project these lines around the corner. Then I'm going to measure in 6 feet. That's from my notes, 6 feet in. And it's very easy to get turned around. So that's why I asked you to kind of take the steps of putting the box in the same orientation as the drawing. Okay? So once again, I'll take this and scribe my lines. And remember what I told you about logic checking to make sure that the lines actually look orthogonal, right? Orthogonal means, do you guys remember that? At 90-degree angles. Huh? It means at 90-degree angles, okay? So the things, this edge is parallel with that one, and that's 90 and parallel to that. So I'm looking at it, it looks pretty good. Nothing looks like it's kind of angling in a different direction. And so that's pretty well laid out the way that I need to cut it. So the next thing I need to do is to simply cut that out. Now, you guys have already gone through the cutting process, so I'm going to try and pick up the pace a little bit. And if you guys get lost in this process, we're recording all of this, and this is all ending up on the class server under 101 for fall. That's why you were asked to bring in your earplugs, because if you need to watch these, we don't have speakers on the computers. I'm sorry? No, the videos are not in Canvas. Canvas doesn't allow you to put that much information onto it. The videos are only on the server here, so you can only see them here.
And that would be on the X drive under $, arch101 fall 2017, correct?
Yes, correct. No, I tried to get them to allow us to set up a Vimeo account and a number of different things, and it's just, when they don't want to let you do something, they just make it really hard to do, so that you, after a while, are just like, I give up. It's not worth it. Okay, so there it is. Now, what kind of subtraction is that? No? Skin deep. Hasn't I tricked you, right? It has not reduced the volume of the cube. It's merely a surface cut. But wait, watch. The magician turns. They're supposed to be able to do this without you guys noticing. Now, what is it? See, now it has a very different visual character, right? Now it becomes a spatial subtraction. It's not finished yet, because I've got to put a roof on this. It's got a hole up there, and doesn't have a floor, right? But that'll be the next steps. So right now, what I'm going to do is release you guys to go back to your desks, lay out that first cut, and cut this first piece. Give you guys about 10 minutes or so to do that, then I'm going to bring you back up and show you how to do the roof. Stop it.
And we're out.